In a previous video, we've talked about the various transformations you can do to a function, and here is a summary of the greatest hits. Now, in this video, we're going to be performing these transformations on a variety of functions. So, given the graph of f of x, sketch the graph of the following functions and state the domain and range of each. I think the key is going to be, let's identify some key points on this graph. I see 1, 2, 3, 4 key points. Hold on, technical difficulties. Can I draw on this now? Okay, so let's use these 4 key points, and if we can do the transformations on these 4 points, that will tell us what the whole function is doing. So I think I'll just zoom in a little bit and make a table of these 4 values. All right, I think I'll make it a little bit long. So we have the x and we have the y. So our first point is -6, -3. All right, so I've got -6 and -3 going on right there. And then next we have -3, 2. So -3, 2. And then next we have -1, 0. All right, and finally we have +1, 4. +1, 4. All right, time to do the transformations. And this is the reason why I made the rows extra long, so there would be room for the transformations. So anything happening outside of the function is happening to the y values. So this 2 out here means that we're going to multiply the y values by 2. So we're going to do 2y because of this. So that is going to make -6 and 4. 2 times 0 is still 0. And 8. All right, now anything happening inside the function is happening to the x values. However, it's going to be the opposite of whatever it looks like. So because we have x minus 5 right here, we're actually going to be doing x plus 5. All right, that is just how this works. So everything inside the function happens to the x values, but it's the opposite of what it looks like. If it seems to be -5, we're going to add 5. If it looks like we're dividing by 2, we're going to multiply by 2. Everything is opposite land in here. Okay, so we're actually going to add 5 to this, and that's going to give us -1. And adding 5 again will give us a +2. All right, adding 5 right here is going to give us a +4. And adding 5 right here is going to give us 6. Okay, and this goes right in line with on our introductory chart here. If we have x minus h, look what we do. We actually do x plus h. So I'm doing exactly what it says on the chart. All right, so these red values are the transformation. So that's what I'm going to actually graph. So ignore the blue values. Those are old and gone. All right, maybe I'll just cross them out. So we're going to have our first point at -1, -6. All right, so -1, -6 is going to be right here. And then our second point is at 2, 4. Okay, so 2, 4. All right, next we have 4, 0, which is right here. And finally 6, 8, which is right here. Let's Let's go a little bit higher. Okay. Now I'm just going to connect the dots, making a similar pattern to what we had before. Okay, I really thought that was going to be red. Let me switch that up. All right, and there you go. This is the graph of the first transformation. And I'm going to color coordinate this, so you see the red here. That's how you know it's going to be the red one. So now I'm going to change colors. Well, first I need to basically recopy the blue numbers down. So let me just do that again. Now, remember, anything happening outside the function is happening to the y values. So everything that I just highlighted in yellow is about to be something that happens to the y values. So that's why I'm going to be doing negative y plus 7, or the opposite of y plus 7. Okay, so the opposite of y is 3, plus 7 is 10. The opposite of this is negative 2, plus 7 is 5. The opposite of this is still 0, plus 7 is 7. The opposite of this is negative 4, plus 7 is 3. So that's the y values. Now, anything happening inside the function is happening to the x values. All right, so this is something that's happening to the x values. However, it's always going to be, you know what, I meant to do this in purple. We got to color coordinate here. So this 2 is happening to the x values. However, everything on the inside happens the opposite of the way it looks. So this seems to be multiplying by 2. So what I'm actually going to do is I'm going to do 1/2 times. I'm going to divide by 2. So I'm going to actually do 1/2 x. And again, looking at our chart, as you can see, if I have a b value here, then what you wind up actually doing for the transformation is 1 over b. You do the reciprocal of that. So that's what I'm doing. I had a b, and now here I have 1 over b. All right, but basically if it looks like multiplication, do division. So if I do that, take half of all of these numbers, then that's going to give us negative 3, negative 1.5, negative 0.5, and positive 0.5. So you can forget about the original x and y value. The purple ones are going to be the ones that count now. Okay, so we've got negative 3, 10. All right, so negative 3, 10 is almost off the chart. All right, we've got negative 1.5, 5. Okay, so negative 1.5 comma 5 would be right here. Negative 0.5 comma 7, that's going to be right here. And positive 0.5 comma 3. Positive 0.5 comma 3 would be right here. All right, let's connect those dots. And there you go. All right, this purple represents the transformation for part B. Okay, let's go ahead and do the third transformation now. Okay, let's start with what is happening to the y values. Anything outside the function is happening to the y values. So these two transformations are happening to the y values. Hold on, I'm going to use green this time. Keep it color coordinated. So that's why I'm going to do 1/2 of every y, whoops. I'm going to do 1/2 of every y value, and then I'm going to do -2. All right, so that's what has to happen. So if I do 1/2 of -3, that's going to be -1.5. And then if I do -2, that's going to be -3.5. All right, half of this is 1, and then 1 minus 2 is -1. Half of this is still 0, but then 0 minus 2 is -2. And half of this is 2, and then -2 is 0. So these are the new y values. Let us switch gears and talk about the new x values. Now, they gave us this friendly reminder here. Before we can deal with the transformations on the inside, they're saying, remember to factor first. Here's what they mean. Let me give you an example before I do the actual problem. If I have f of 2x plus 4, normally a number in this position is telling us that this is moving the graph to the left 4. It's the opposite of what it looks like. So you'd say to the left 4. But you would be wrong if you thought that. And that's because of this 2 right here. You have to take that outside of parentheses before you can judge what's going on in here. In other words, you have to take this 2 outside. In this case, it's a GCF. But even if it wasn't, you would have to take it out anyway. And then, so obviously inside the parentheses, I will now have x plus 2 because I factored out that 2. Technically, the way I get what goes inside the parentheses is to divide by the thing that I just pulled out. And that gives me x, and it gives me 2. Now you can see that instead of being left 4, it's really left 2. So that gives you an idea of what I'm talking about. Now, applying that to this problem, here we have -x plus 4. You could think of this as -1x plus 4. And guess what? This -1 has to come outside of parentheses before we can judge the problem. So this will actually be -1x minus 4. Okay? So really, what we have is 1/2 f of -x minus 4, and then -2. Okay? So the key is what we have going on right here is -x minus 4. Okay? So the two transformations are this and this. This is what will happen to the x values right now. Okay, so yes, I'm going to be doing negative to these x values, but also I need to add 4. Okay, I need to do a plus 4 to this. So the opposite of this is 6, and then plus 4 would be 10. The opposite of this is 3, plus 4 would be 7. The opposite of this is 1, plus 4 would be 5. The opposite of this is -1, plus 4 would be 3. So these are the new x and y values. So we can throw these out, and now we can graph the green numbers. Okay, so 10, -3.5. All right, so here we have 10 and negative 3.5 would be right here. 7 comma negative 1 is right here. 5 negative 2 is right there. And 3 0 is going to be right here. And we'll connect the dots and we'll be done. Oh, I really wanted that to be green. Technical difficulties. And that's it. All right, so here's a bird's eye view of problem number 1. That's what you should have. Okay, let's move on to another graph. We're going to be doing the same thing. Before I even get too carried away, let's do the factoring. So on problem number 2, part A, I see I have this 2x minus 6. I know I'm going to have to pull this 2 outside of parentheses. So this will really be 2 times x minus 3. So make sure you're looking at that for the inside the function part. All right, now let's talk about the key values. I'm going to use this as a key point, and I'm going to use this right here. Here's another key value, and here is a key value. Those 4 values really tell me the story of this function. So let me make a little chart of those 4 values with extra long rows to accommodate the transformations. So our first point here is negative 2 comma 3. So we're going to have negative 2 comma 3. And then we have negative 1, 0. And then we have 0, negative 1. And then we have 1, 0. Remember, everything happening outside the function is happening to the y values. So that's why my new y value is going to be 2y plus 1. So I'm going to be doing 2y plus 1 for my new y values. So let's see. That'll be 6 plus 1 is 7. 0 plus 1 is 1. Negative 2 plus 1 is negative 1. And again, 0 comma 1. So I multiplied everything by 2, and then I added 1 to that. So that gives me the new y values. Now, for the new x values, I look at what's going on inside the function. So here are the 2 transformations that are happening inside the function. Be careful though, everything that happens inside the function is the opposite of what it looks like. So if it looks like I'm multiplying by 2, I'm really going to be dividing by 2. So that's why I'm going to have a 1/2 x. All right, because I'm really dividing by 2. This minus 3 is actually a shift to the right 3. So that's why I need to put a plus 3 here. So half of negative 2 is negative 1. Plus 3 is positive 2. Half of negative 1 is negative 0.5. Plus 3 is 2.5. Half of 0 is still 0. And then plus 3 is 3. And half of 1 is 0.5. If you add 3, that is 3.5. So we have our new x values and our new y values. We are ready to graph. Okay, so first we have the point 2, 7. 2, 7 is going to be right here. All right, so this is the new point that used to be this point. Next, we have 2.5, 1. All right, 2.5, 1 is right here. All right, that's going to be what happened to this point. And all right, next we have 3, -1. 3, -1 is right here. That's the new, what happened to this point right here. Okay, and then we have 3.5, 1. And 3.5, 1 is going to be right here. And then if we just connect the dots, there you go. So we did all of the transformations. All right, now let's look at part B. For part B, and this is problem number 2, part B, watch out that we have to factor first. So what we mean by that is the negative sign that's in here needs to come outside of parentheses, and it's going to look like this, -x plus 3. All right, so if you have a B value, all right, if you have something in this position, you have to take it outside of the parentheses like that. Okay, we're going to do this problem in purple. Let's start with what's going on with the y values. So the y values are affected by anything that's happening outside the function. So this is the only thing that's going to affect the y values. That's why the y value will be the opposite of y. So this is going to be -3, 0, +1, 0. That's pretty easy. What about the x values? Well, the x values are affected by anything that's happening inside the function. Now we pulled it up here, but there are two things happening, this and this. Because of the little negative sign, I know I'm going to have -x, the opposite of x. Now this +3 is actually a translation to the left 3. So I'm actually going to do -3 after that. So opposite of x, -3. Everything on the inside is the opposite of what it looks. So the opposite of this is 2. And then -3 is -1. The opposite of this is 1. And then -3 is -2. Opposite of 0 is still 0. -3 is -3. The opposite of this is -1. And -3 is -4. So we have our new x and y values. So we can throw out the old and plot these points. All right, let's see what we've got. -1, -3. So -1, -3 is going to be right here. -2, 0. That's going to be right here. Yeah. -3, 1 is going to be right here. And -4, 0 is going to be right here. All right, so we just need to connect these dots in a smooth way as best we can. And there you go, we've done it. Okay, that is the transformation part B. So time for number 2, part C. We'll do this one in green. So let's start with what's happening to the y values. Anything happening outside the function is happening to the y values. That's why the new y values will be y minus 5. Anything happening inside the function is going to be happening to the x values. So there are actually two transformations here. The negative sign is like one transformation, and then the 1/2 is another transformation. Okay, so because of that negative sign, yes, I'm going to have opposite of x. Well, I'm going to have another number in there. Anyway, I'm going to have the opposite because of that. The negative sign will give me a negative sign. But this 1/2, which is dividing by 2, we're actually going to do the opposite and multiply by 2. Okay, so it's going to be negative 2x. You had to do the reciprocal here. So inside the function, you do the opposite. If I see a plus 5, I wind up doing a minus 5. If I see a 1/2 x, I wind up, so if I see x plus 5, I wind up doing minus 5. If I see 1/2, I wind up doing 2x. All right, so anyway, don't know why I left that much space. We're doing negative 2x. So that's going to give me positive 4. Negative 2 times 1 is positive 2, and then 0, and then negative 2. Wait, I didn't actually do the y value. So minus 5. So 3 minus 5 is negative 2. 0 minus 5 is negative 5. Negative 1 minus 5 is negative 6. And 0 minus 5 is, again, negative 5. Now we have our new x values and y values. We are ready to graph. 4 comma negative 2 is right here. And then we have 2 comma negative 5, which is going to be right here. Okay, and 0, negative 6, which is right here. And negative 2, negative 5 is going to be right here. All right, so you can see what's happening with our swoop. So let's just go ahead and do our best to connect those dots faithfully. And there you have it. Those are the transformations performed.